Hello class, it's Mr. Cowboy here again, and today we will be looking at ratios and proportions. So for this lesson here, we're actually going to go over some of the skills we saw in the previous lesson dealing with taking fractions and putting them into lowest terms. And you're going to see that ratios and fractions are very, very similar approach when we're trying to simplify them. So let's get straight to it here. So when we're taking a look at ratios here, what we want to understand again when we're looking at them is that we're going to approach it just like we did with fractions, and by finding what's called the common factor. Now you're probably asking, what's the difference between ratios and fractions? Well, basically with ratios, all it is a way of expressing comparing two different quantities. So for example, if I take a class of 16, okay, what I have here are 6 boys, okay, and 10 girls. Now, what I want to do here is just to go through how different ways that we can express this here. Specifically, in this case, we're going to take the ratio here of 6 to 10 and express it into what's called simplest form, which is basically the ratio version of taking a fraction and putting it into lowest terms. And you're going to see when we look at these examples that the approach is exactly the same. So, for example, if we have a ratio of 6 to 10, what we're going to do here is to find a common factor. Now, 6 and 10 are both even numbers, so the most common number that goes evenly into both 6 and 10 is going to be 2. So all we need to do here is take each of these numbers and divide it by 2. So for example, I'm going to take 6, divide that by 2, that's going to give me 3, and I'm going to take the 10 and divide this by 2, and that will give me 5. So 6 to 10, when we reduce it into the simplest form, is going to reduce itself to 3 to 5. Okay, so you can see that the approach is exactly the same as taking a look at fractions and putting them into lowest terms. So let's take a look at more examples. Okay, so what we have here is 5 and 15. So when you're looking at numbers, okay, just take a look to see if any of the numbers given to you go evenly into each other. So in this case here, 15 does not go into 5 because simply 15 is a bigger number than 5. However, 5 does go into 15. So in this case here, the common factor is going to be 5. So in the next example here, we're going to take 5 here, divide this by 5, that gives me 1. We're going to take 15, divide this by 5, and that'll give me 3. So 5 to 15, when we put it into simplest form, is going to be 1 to 3. All right, now if you take a look at 6 and 8, okay, you're going to see here that 6 does not go evenly into 8, and since 8 is a bigger number than 6, 8 doesn't go into 6. Okay, now when you're looking at this number here, 6 and 8 are both even numbers. So the most common even number that will go evenly to both numbers here is, well, you guessed it, it's 2. So all we're going to do here is divide each of these numbers here by 2. So 6 divided by 2 is going to give me 3, and 8 divided by 2 is going to give me 4. So when we divide both of, when we now take those numbers, 6 to 8 can now be expressed as 3 to 4 in simplest form. All right, so in the next example here, okay, notice what we have here is 12 and 4. Now 12 and 4 again are both even numbers. Now in the previous examples here, the most common even number that goes evenly into those two numbers will be 2, but there is a number that goes evenly into both. Okay, and in this case here, another even number that goes into both 12 and 4, well, is going to be 4. Okay, so in this case here, we're going to take 12, divide this by 4, that's going to give me 3, and we're going to take 4 here, divide this by 4, and that gives me 1. So 12 to 4 in simplest form is going to be 3 to 1. Now for part D, notice that this one here is different only because there are 3 numbers which make up the ratio. Okay, so if you look at 3 numbers here, again, take a look at each of the 3 numbers to see what number goes evenly into all 3. So let's start off with the ones that we have first. Okay, so if you look at 15, okay, 15 doesn't go evenly into 21, and since 15 is bigger than 3, 15 doesn't go into 3. Okay, and same thing with 21. Okay, 21 is bigger than both 15 and 3, so 21 can't be the common factor. So the only number that can go evenly into both 3, 15, and 21 is 3. So just like we did in the previous examples, we're just going to divide each one here by 3 to give us the numbers which will make up the ratio in simplest form. So when we take the 15, divide this by 3, it gives me 5, and we take the 21, divide it by 3, it gives me 7. So the ratio in simplest form for this one will be 1 to 5 to 7. Okay, that's pretty much it when it comes to expressing ratios and putting them into simplest form. So the next thing now, we're now going to take a look at ratio and how it relates to proportions. So basically what we're going to do here is we're now going to be learning how to solve for ratios to express it as a proportion. And basically what we have here is that if we have a ratio of 6 to 8, for example, okay, when we take a look at a proportion and we go through finding what number goes into both, okay, that would be an example of a proportion where the two fractions are actually equated to each other. Okay, and what we're going to do here is actually going to be a technique called cross multiplication or cross product. And what we want to do here is that we're going to be looking at two proportions and we'll be solving for the unknown quantity. Okay, and we're going to look at cross multiplication, which is an algebraic technique, and it's very important that you understand the form and how to set it up here, because it is going to be something we'll be seeing later on when we're looking at the core material from this course here. And what we're going to do here is that when we're solving for the proportion and when we're solving for the unknown quantity, we're going to establish what's called a variable, which is going to be a letter which represents the value that we do not know. And what we want to do here is learn how to set this up so you can see how cross multiplication works. So it says here, find the missing term x here in each equivalent ratio. Now I notice for the questions that you see on the screen there that we do have a ratio as well as an equal sign in between. So the first step that we need to do here is to set up a proportion. And the way we do that is to take each ratio and express them as a fraction. And this is how you can see here where ratios and fractions are indeed identical to each other. So you're probably asking, well, how do I represent 2 to 5 as a fraction? Well, the way we do that is just to express it as 2 over 5. Okay, simple as that. So if 2 to 5 is 2 over 5, then 6 to x is going to be 6 over x. Now, the next thing I want to show you here is the technique, the algebraic technique of cross multiplication. And the way we do that here is we're going to multiply like this. Okay, and what I mean by that is we're going to multiply the 5 to the 6 and the 2 to the x. So when I multiply the 2 to the x, or anytime you multiply a number to a variable, you're always just going to get that number attached to that variable. So for example, 2 times x will just give me 2x, and then 6 times 5 will give me 30. Okay. Now the final step, what we want to do here is we're going to again perform the proper algebraic technique of isolating the variable. Then the way we do that, again, when we have 2x equals 30, where the 2 and the x are grouped together by multiplication, which we did in the previous step, to solve for x now, what we're going to do here is we're going to divide both sides by 2. And you always divide both sides by the number that's attached to the variable. Now, the reason why we divide both sides is because in math, what you do to one side, you do to the other, especially when it comes to multiplication and division. So when we do that, I want you to take a look what happens to the 2 2's on the left side. When you divide a number by itself, it just cancels itself out. And you notice that when I show you that, the letter x is remaining. Okay, and then 30 divided by 2, that's going to give me 15. All right, so you've seen the first example here. So take a moment to try the next example for yourself. You can pause the video if you want. Now you notice the set of instructions is exactly the same. So 6 to 11 can be expressed as 6 over 11, and then x to 44 can be expressed as x over 44. So in the next example here, we're going to cross multiply. So 11 times x gives me 11x, and then 6 times 44 will give me 264. Now, this last step where you isolate the variable, all you do here now is divide both sides by the number attached to the x, which in this case here is 11. Again, just like the previous example, all that does is cancel 2 11s on the left side, and then 264 divided by 11 is going to give me 24. All right. So let's take a look at one more example, and you notice I kept the instructions, they're exactly the same. So what we have here will be 3 over 7 is equal to 21 over x. So all we need to do here again is to cross multiply. So 3 times x is 3x, and then 7 times 21 will give me 147. And last but not least, we divide both sides here by 3. Okay, and then 147 divided by 3 will give me 49. All right. So again, get in the habit of now using a variable to establish an unknown and to use cross multiplication. Okay, and the algebraic steps behind it in order to solve for a variable. Again, this is going to prepare you for the core material in the course when we're going to be dealing strictly with variables when solving for unknown quantities. All right, so let's take a look at an application problem here. Okay, good. Just to now introduce you to the structure of a word problem. So it says here in a box of Smarties candies, the following colors were present. We have 12 pink, 14 blue, 10 red, and 14 green. Now, what we want to do here is to take those numbers, okay, and to express it in simplest form. Now you notice that what we want to do here is to group them according to the color that's defined in the question here. So it's write the ratio of pink to red to blue to green. Okay, so pink to red to blue to green is written as 12 to 10 to 14 to 14. Okay, so we have 4 sets of numbers, well technically 3 because we have 2 sets of 14s. And what we want to do here is to find the common factor, which is a number that goes evenly to all of them. Now, if we take a look at each number separately here, okay, starting off with 12, okay, 12 does not go into 10 because it's bigger than 10, and 12 doesn't go evenly into 14, so we know it's not 12. Okay, 10 goes into 10 doesn't go into 12 evenly, and it doesn't go into evenly into 14 as well. Okay, and since 14 is bigger than 12 and 10, 14 doesn't go evenly into those numbers as well. So we know it's none of those numbers you see there. Okay, so if you look at 12, 10, and 14, okay, you should notice that these are even numbers. So again, just like we've done in the previous examples, the most common even number that goes evenly to all those numbers is going to be 2. And all we're going to do there is divide each of those numbers here by 2, okay, to give us our numbers that will make up the simplest form. So 12 divided by 2 is going to be 6. 10 divided by 2 is going to give me 5. And then 14 divided by 2, which we can do for both, is going to give me 7. So the ratio in simplest form for 12 to 10 to 14 to 14, okay, is going to be 6 to 5 to 7 to 7. All right, so this is now going to be the numbers that we're now going to use to look at question B. So it says, look at the ratio here of 6 to 5 to 7 to 7. And it says, how many parts are there altogether? Okay, and the way we do that is to take those numbers, okay, and then I'll just add them all up. So when we add those up there, 6 to 5 to 7 to 7, we now have a total of 25 parts, okay? Another way you can look at this here is that when you're taking a look at the numbers over here, what we started off here initially was, let's say, a box of Smarties that had 50 candies in it. And basically what we have here is that we can express that in different ways here. And in this case here, when we put it into simplest form, we now basically have a box of 25. Now, what we want to do here is we're going to use the number of parts based on the previous calculation to now solve for a bigger box. So it says using the ratio in simplest form, okay, and you see in the right hand side there in the box in red. What we want to do here is determine the number of each color if there are 150 Smarties in the box. And the way we set that up here is we're going to solve for each color separately using proportions from both the total number of parts, okay, and the number out of the 150 Smarties. And the first thing we're going to do here is to set up a proportion. And the way we're going to do that is to take a look at the total number of pink parts over the total number of parts, which are the numbers in the red box there. So that will make up the left side. Okay, and on the right side, we're now going to solve for the number of pink parts in the box of 150. Okay. So the next step here is, since we want to solve for the number of pink, we now need to establish a variable. And the way we declare that is we're going to tell ourselves that we're going to let P to represent the number of pink Smarties in a box of 150. Now, what we want to do here using what I have on the screen there is just put in the numbers which make up those different things there. Okay, so for example, on the left side, we have pink parts over total parts. So notice in the red box there, based on the simplest form, 6 out of 25 parts will make up the left side. So on the right side, since we're solving for the number of pink, what we wind up getting there will be P over 150. Now, once we have the two fractions on both sides of the equal sign, we can now cross multiply, just like we did in the previous example. So what we have here is 25P on the left side, and then 6 times 150, which gives me 900. And last but not least here, we're now going to divide both sides by the number attached to the letter in this case, which in this case is 25. Okay, and the reason why we do that, as I said in the previous example, okay, the two 25s on the left side cancel out, and we wind up getting 36. So in a box of 150, okay, there are 36 pink Smarties. Now, what I want you to do here is just pause the video for a moment, and I want you to solve for the remaining 3 quantities in the exact same fashion. The only difference is that you will be dealing with different numbers. All right, let's see what we have here. In order, the set of instructions are exactly the same. So this time here for red, okay, we're going to take a look at the total number of red parts over the total number of parts from the simplest form. And on the right side here, we're going to find out the number of red parts in the total of 150. Okay, so since we're looking at red, okay, it's naturally, again, easier to use R to represent the number of red Smarties here. So if you look at the right side there, in the simplest form, 5 out of 25 parts were red. So on the right side, we're solving for the number of red Smarties of 150. So what we get there will be R over 150. Okay, so again, we cross multiply. So 25 times R will give me 25R. Okay, and 5 times with 150 will give me 750. And last but not least, divide both sides here by 25. Okay, and from here, this will give us a total here of 30 red Smarties in a box of 150. All right, now I want to talk about the next example here because there is kind of a shortcut for it, and it deals with the color blue. Okay, so let's set up the proportion first. So we're going to take the total number of blue parts over the total number of parts, and we're going to let it equal the number of blue parts over the total number of Smarties. Now, since we're solving for the number of blue, we're just going to simply let B to represent the number of blue Smarties in a box of 150. Now, based on the simplest form, there are 7 out of the 25 parts which are blue. Okay, and on the right side here, we're going to put B over 150, and we're going to solve for the B because the B is what we don't know. So when we do that, okay, we're going to cross multiply. Okay, and then from the last step here, divide both sides by 25 because it's a number that's attached to the letter. So what we can now have here is a total of 42 blue Smarties. Now, this is before I'm gonna explain a shortcut here simply because if you take a look at the simplest form, okay, the number of blue Smarties and the number of green Smarties are exactly the same. So you really, in essence, don't have to solve for the green because it's going to be the exact same thing as the blue. You just need to explain it. However, if you want to solve for it, by all means, you can do that. So I'm just going to quickly go through that. So same approach. We're going to look at total green over total number of parts. And we're going to find the number of green over the total number of Smarties. And we're going to let G represent the number of green. So all we're going to do here, okay, we have 7 over 25 is equal to G over 150. Notice the proportions are exactly the same. The only difference in this case here, the letter just happens to be the letter G. Okay, so we cross multiply. So 25 times G gives me 25G. 7 times 150 gives me 1050. And last but not least, divide both sides here by 25. And you guessed it, we will wind up getting the same number as the blue, okay, which is 42 green Smarties. All right, so that wraps up this lesson. So you can, if you turn to the page, you can start working on the questions associated with this section here. And I will see you in the next lesson.